Okay, what we want to cover today is another method to solve quadratic equations where we cannot factor the equation itself. So let's take a look at the following. Um, I have four different quadratic equations, and so the question is, we don't want to solve them, we just want to identify what's the best way to solve these. So hopefully in the first one you see that you can factor using dots, or you can use the radical method, meaning you can move the 49 to the other side and solve it that way by taking the square root. And the next one, hopefully you're seeing you cannot factor because 20 is not a perfect square, so you have to do the radical method, which means you add 20 to both sides, you get x squared equals 20, so x is equal to plus or minus the square root of 20. Excuse me, and then you could just look that up on the calculator. Next one, hopefully you can see that you'll factor using I am. And then the next one, I can't factor, so I'm going to use the complete the square method. Okay. Now, remember what we said yesterday is we would use the completing the square method when, and the answer to that is when the equation cannot be factored. Now, let's take a look at the following. Suppose I have the quadratic equation 5x squared plus 13x minus 19. Okay? And remember what we said yesterday, we prefer, or we want the coefficient of a, not prefer, we want the coefficient of a to be 1 because that allows us to use that little formula to figure out what the c needs to be to do that. Now, if you look at this quadratic equation, what's the problem here? Well, hopefully you're saying to yourself, to get the coefficient of a to be 1 results in fractions that are difficult to work with. So in other words, I would have to divide everything by 5, and now I'm going to be dealing with 13/5 and 19/5, and now I've got to take half of 13/5 and square that. Not that it's impossible, but it's a mess. So there is another method to solve these types of quadratic equations, and the method is a derivation of the completing the square method. I'm not going to walk through how this formula is derived, okay? But this is what's called a quadratic formula, all right? And quite simply, like most formulas, all you are doing is plugging in the values for a, b, and c and solving. Now, excuse me, the thing about the quadratic formula, it can be used any and every time, no matter what. So in other words, if you are ever looking at an equation and you are stuck and you are not told how to solve it, you can always revert to quadratic formula. So let's take a look at this equation. And if I were to solve it by using factoring, well, hopefully you would see I'd get x minus 4 times x plus 2 equals 0. And so that I get x is equal to 4 and x is equal to negative 2. Okay? Well, now let's look at how the quadratic formula works. And I'm doing it with this type of problem just so that you see how it works when everything works out nicely. A is 1, B is negative 2, C is negative 8. So I plug into my formula x equals negative, a negative 2. Most common mistake, it's a minus sign, and you have to change the sign of whatever b is. plus or minus. The reason it's plus or minus, it's a quadratic equation. We're expecting two answers. Square root b squared, negative 2 squared, minus 4 times a times c. All of that is divided by 2 times a. Okay? Now we just do the math. This is a positive 2 plus or minus the square root of 4 plus 32 over 2. And just move this down. So x is equal to 2 plus or minus the square root of 36 over 2. Now, once you see, and we're going to talk about this in a second, that you have a perfect square under the radical sign, that'll tell you that what you had was something that could have been factored. So now how do I do this? Remember, we got two parts. So I'm going to do 2 plus the square root of 36 divided by 2, 2 minus the square root of 36 divided by 2. So x is equal to 8 divided by 2, which is 4, and x is equal to negative 4 divided by 2, which is negative 2, which are the two answers that we had above. Okay? So now let's see how this works when things don't work out so nice and neat. Okay? Oh, and we're going the wrong way. There we go. So I want to use the quadratic formula to solve 3x squared plus 19x equals 154. Now, first thing is you got to make sure you true this up to equal 0. If you don't do that, it's not going to work. Signs are going to be off. Okay? A is 3, B is 19, C is negative 154. Okay? It should be somewhat obvious to you to use the quadratic formula based upon the coefficients of A and B and the value of C. Negative 19 plus or minus the square root of 19 squared minus 4 times 3 times negative 154, and all of that is divided by 2 times 3. So what do we get? Negative 19 plus or minus the square root of 361 plus 1848 divided by 6. And here we go. So x equals negative 19 plus or minus the square root of 2209 divided by 6. Now, we'll do this in class, but when you do this on your calculator, okay, you should, if it doesn't work out to be a perfect square, punch everything into the calculator as it exists. But in this case, it works out to be 47. And we get x is equal to 4.6 repeating, and x is equal to negative 11. Okay. Now, the final thing I want to cover with you is what's called the discriminant. The discriminant is going to tell us something about our quadratic equation. Now, if you think about it, and we've talked about this at the beginning of the unit, our quadratic equation can have one answer, two answers, or no answers. Okay? And we saw this with graphing. One answer would be something like where it hits the x-axis at 1 point. Two answers is when it hits the x-axis at 2 points. And no answer would be when it does not hit the x-axis, so that there's no real number solution. Okay? The discriminant will allow us to figure that out. And it's just as helpful sometimes to know ahead of time what type of answer or the number of answers you're going to have. So, a quadratic equation can have 1, 2, or no answer. Okay. Or solution. Okay? The number of solutions can be determined by using the discriminant. The discriminant is the expression under the radical sign in the quadratic formula. So the discriminant is b squared minus 4ac. And if you think about it logically, it kind of makes some sense for you. So I have three possibilities. My discriminant, this orientation is so poor. Okay. Sorry about that. All right, so my discriminant can be a value greater than 0. It can be a value equal to 0, or it can be a value less than 0. Now remember, whatever this discriminant is, it's under the radical sign. So an example is where it's greater than 0 is x squared minus 6x plus 7. All right, and the reason for that is when I factor this, I am going to get two different answers. Now, it's equal to 0 here because if you look, this is a perfect square trinomial, which means there's only one answer. And in this one, the reason it's less than 0 is what you're going to see is there's no solutions. Now, why are there no solutions? Well, if you solve this with the radical method, you'd get x squared equals negative 25, which means x equals plus or minus the square root of negative 25. There is no square root of negative 25 in the real number system. So, number of solutions, 2 real, 1 real. Okay. So take a moment, and for the two quadratic equations at the bottom, tell me what number of real number solutions you are expecting. So my discriminant in the first one is b squared minus 4 times 1 times 3, which is 4 minus 12, which is negative 8. That means under my radical sign is a negative 8. I have no solutions. Okay? Second one, I have 12 squared minus 4 times 9 times 4, which means I have 144 minus 144, which is 0, and that means I have one solution. Okay, so today's lesson, we've used the last method of solving quadratic equations, which is to use the quadratic formula. Quadratic formula can be used anytime. However, it's preferable when you have equations that definitely cannot be factored and completing the square is more difficult than need be.